Hello, everyone. Good morning, and welcome to the Building the Edge webinar hosted by CS Solutions. Thanks to all those who are logged in. So my name is Arvind Ramchandra, and along with the rest of the team, we'll be hosting a webinar and talking about a whole bunch of topics around what goes into edge and IoT computing, what are the different models that are driving it, and what are the different architectures and so which are available right now. So a quick intro. So along with me today, I'm going to have Scott Rook, who is also joining me, and so we both together will be talking about all of these topics under edge computing. So a quick intro from my side. My name is Arvind Ramchandra. I'm the VP for Technology at ACS Solutions, and based out of Atlanta. Scott, would you like to introduce yourself?
Sure thing. Scott Rook. I'm a senior principal cloud architect and lead many of our cloud clients through cloud transformations and cloud adoption.
Great. So before we dive in, a quick look at so what we're going to talk about today. Right. So we'll talk about what is so we'll see edge and IoT in action. Right. So how actually does it? So how actually does it get implemented in the field? But then we will sort of work backwards from there to say what goes into providing those kind of solutions. What are the kind of decisions that right, so customers and teams need to make, right? So when it comes to choosing what's the right edge approach today, we will go a little deeper into the different kinds of services that are available on edge platforms. What are the different models and what are the different architectures that are available? From that, we'll then do a little bit of an introduction and a deep dive into some of the patterns, right? So which have emerged in the last year or two since edge computing and IoT services have been rolled out. And we'll also talk about what ACS itself is doing within our company in terms of providing these kind of edge solutions. So a quick overview about ACS itself. So we're a private company headquartered in Atlanta, about 20,000 plus employees, and we just crossed $1 billion plus in revenue. We have offices across pretty much the whole of the United States, and a presence in India, Europe, Australia, Canada, Latin America. We have delivery centers in USA, in Mexico, India, and Taiwan, with smaller ones in Israel, a couple that are coming up in Europe. So we focus mainly on the mid-market to the enterprise and clients. So jumping into the topic itself, so this is how the technology landscape for edge and IoT looks today. So IoT has been around for the last about 6 to 7 years and has gone mainstream. So where we have devices and sensors pretty much in every business process and almost all kinds of products, all the way from your cell phone to automobiles, to buildings, to manufacturing plants, to all kind of transportation and so on, equipment. So across the board, we have seen that under the general name of things, right? So we have device and sensor built into almost all aspects of our life. But the technology landscape typically starts off with devices and sensors, right? So where you try to onboard device, you try to understand what's happening with the device, and trying to collect data. And then usually you have some form of a gateway. So whether you're going with something that is on-site, whether you call it local, whatever the name that you might give. But you need a way and a mechanism of getting all of the data out of the devices within the products and then getting it back to where you'd like to process that. So with cloud itself becoming mainstream in the last about 4 to 5 years, cloud has sort of become the de facto backend platform where a lot of these data and mechanisms and things get processed, whether you're aggregating it, whether you're performing analytics, whether you're trying to do machine learning, etc. All of these other activities that go along with that. So, but where do these components stand as of today? So if you see, so let's take it part by part. So closer to the product where the IoT enablement happens. So we're seeing that there are a lot of devices which already have, and so it support about 4G and 4G and LTE. So almost 80% of the market currently, wherever there is IoT embedded involved, already supports 4G LTE. And it is planned that about 6% of that will now start moving into 5G, where they'll be able to connect up to some kind of a 5G adapter or a 5G gateway. And the anticipation is that at least 1 billion of these will be there by the end of next year, which is 2022. The other important component is the connectivity aspect of that, which was more 4G LTE, but 5G becoming more prevalent, whether it's indoors or outdoors. 79 operators across the world have already made commitments, and 24 markets have already gone live as of last year, this thing, and this year it is even more. So we're seeing that by another 3 to 4 years, more than half of North America will pretty much be covered by 5G. We already see that the major metros and the major carriers like AT&T, Verizon, and T-Mobile have already started providing cellular equipment, right, so it can support 5G. Which then moves into the next part, which is, so what about the computing aspect of that? So that's where a lot of services have been rolled out that support edge analytics, which is as close as possible to the source of the data and where the IoT device itself might be embedded. So we're seeing a lot of partnerships come out between the hyper providers like AWS, Azure, and GCP, for partnering up with telecom carriers like Verizon, AT&T, in North America, and then Vodafone in Europe, and Telefonica, and of course, right, so other kinds of carriers across the world. So that rollout has been happening. Plus, an interesting aspect is that there are other technology providers are also jumping into the fray and providing their own different kinds of kits, whether it is NVIDIA, which is coming out with its entire AI kit that can become part of an edge service, whether it is Hitachi, whether it is NEC, Ericsson, Nokia, they're all jumping into this with different kinds of solutions. So things are definitely beginning to look interesting. And most of them, as we'll see in the next few things too, as we keep talking through this, you'll see that a lot of interesting use cases and applications are getting and emerging over there. So let's jump into a little bit about what we really mean. How does this all come together? Like I was saying, let's go backwards, right? So what you see on the left-hand side is a traffic stop is saying, right, so from a junction in Taiwan, right? So that is the video stream which is coming in. What you see on the right is that entire video stream that has been processed, right? And so you can see that it's pretty high-speed traffic, and it's got a variety of different objects within that. So if you need to do multiple object detection, because you need to be able to process in less than 10 milliseconds, there is a high amount of data coming in, obviously because there's a video stream, but we also need to do a lot of tasks. I'm going to hand this over to Scott right now. And so from here on, so he can go into some of these details about, what drives something like this, right? And so because this is a very good example of an edge, an IoT use case in action. Scott, over to you.
Thank you, Arvind. So the purpose of viewing this video here of these two streams of video side by side isn't so much the AI kind of ML object detection per se, but more about if you have devices and you need to do compute and you have to decide how and where am I going to do that compute, we wanted to take a look at more from the operations, the how do you get it implemented point of view, and less about the AI ML. While we can talk about that in another webinar, today will be more focused on just more around the architecture and the devices and what your options are. And so, as Arvind mentioned, in this particular case, if you're trying to, do some data analysis, and you have latency requirements, let's say 10 milliseconds, moving that data from where it originates to a regional data center is going to exceed that that time window. So those are some of the criteria that factor into what type of architecture do I come up with. So if we go into the next slide here, what we're looking at is a set of parameters that our company has come up with to help guide organizations through that process. And one of the things that, if you'll look at these, they're not in any order, they're not, alphabetized, they're not, prioritized. They're just a set of parameters that helps inform a decision. So if your latency of your use case has, less than 10 milliseconds, or you have a tolerance between 110 and 100 or 100 and 1000, those are factors that would come into what type of implementation you'd want. Also, location, is the device that's generating the data mobile or is it fixed? And what type of analytics do I need? Is this going to, be used to provide machine, real-time, near real-time analytics and inform, users to take certain actions, or do I need to do some sort of dashboarding? Do I need to have the ability to be offline, meaning that if my connectivity to where it's getting processed were to be offline, what would happen? What would be the implications on the location? Data management, how much data are you generating? Where is it going? Remote management, how do I get my devices to all look the same, to have the same firmware, to be able to report back on status, to know what the security status of each one is, monitoring of each one, security, compliance. These are all characteristics that help inform a decision around what type of architecture would make the most sense based on the use case. So looking at the next slide, what we've done here is try to lay out in a visual way some of the things we just discussed in the previous slide. So if you look at the slider bars at the bottom there, where we tolerance for latency, what sort of data processing or compute needs do you have, and what are you going to do with the data? Those three characteristics are going to help inform where the processing and what type of edge architecture makes the most sense that would help drive a particular use case. So the first one here was a side edge. The characteristics of something that would be in what we're calling model 1 or a side edge is an application or use case that has ultra low latency requirements, something that's greater than what it takes to make the round trip from where it originates back to a data center and back to a device. If it exceeds that time period, then this implementation meets that criteria. If you've got critical data that has to be acted upon, and again, that latency to where it gets processed to bringing it back is greater than your tolerance, then this is why we would pick this type of implementation. Looking at model 2, this is local edge. So this is an extension of the first, but a side edge would be something that would most likely be plugged into a local network with inside a facility. Here in a local edge, you might set up your own private 5G network, but it's still near where the data is originating. So again, this has ultra low latency. It might be a private network, and some of the criteria would be a near real-time notification. Looking at model 3, this is where we get into metro edge, or what you may have heard as a wavelength zone. It's the cloud providers partnering with the cell phone providers and providing compute resources inside the data centers, the distributed data centers of the cell phone providers. So here they can provide 5G connectivity to their users, and we can deploy resources in the cell provider's data center and connect closer to where the data is originating from and connecting to. So this has a different type of model. Obviously, over on the far right, we don't have a model for that because that model exists today. That's your traditional regional, cloud provider. So looking at the next slide here. So in manufacturing and product use cases, there are some different types of devices. Now, Arvind mentioned smart products where you've got embedded IoT or healthcare devices that have the monitoring built into them. There's robotics and drones. wanted to take a look at the digital manufacturing process. One of the things we found is organizations that have made a big investment in their manufacturing line precede the IoT space. So what that means is that the devices, the manufacturing equipment today has already been paid for or is being paid for without IoT enablement. So trying to retrofit that prior investment is being done outside of the device itself. So you'll see here we've got vision analytics applied to a manufacturing bottling plant, where it's taking a look at how much volume is filled on each one as it's passing through at line speed. And that's important because they can do quality control characteristics much better at the line and processing where the data is generating. Putting that on a line out to a regional data center to do processing there, if they're trying to make a chain data center, isn't really going to help them make real near real-time decisions. So if we look at this matrix, the parameters we just discussed, and apply that prior example use case to it, I've highlighted a few of the different things that make the most sense. Their latency requirements are, they need to be less than 10 milliseconds because they want to be able to make a change to the manufacturing line, the bottling line, as it's happening, not 2 seconds or 10 seconds later. It could cost them a lot of money to make those changes. So an on-site edge would be a good implementation for that particular need. Near real-time analytics, again, I want to be able to analyze the information that's coming in real time, make a decision on it, and have someone act on it. We've got edge containers, so that's the FPGA or GPU-based systems that could be installed in the manufacturing facility. And the other characteristic there is that if there was any disconnection between the manufacturing facility and the cloud provider where that processing would happen, having it work offline allows them to continue on with the business without being dependent upon the connectivity to the cloud. So if we move on to the next one here, just recapping the prior example that we've been looking at, this would be the implementation of a site edge architecture. It's got ultra low latency requirements. We're trying to do critical data analysis so that we can inform a person in near real time. So if you look at this at a more higher level of all the different components, from the site edge to how we're going to get connected to the edge, back to our public cloud and what we do with the data, it's not that we're doing all the data in and running only in the site edge, but this isn't part of a larger solution. So this was done for on AWS Cloud. If we go to the next slide, I want to highlight some of the characteristics that, as I mentioned when we first started discussing this, is these are things that are going to be common across not just this bottling line, but across other types of edge computing needs around the IoT space and doing compute closer to where data exists. So the thing that's happening is we see deployments are going to need to happen more often and go to more places. So having that CI/CD and the provisioning, the deployment process well defined for one solution is something that you could pick up and provide to another solution, another use case. So even though you might have two different business units trying to solve different problems, they're still going to have the same common problem, which is I need to get my stuff pushed out. Data transformation and monitoring of the data. Again, I have to make sure it's secure. I need to know where it's at. I need to know how to transport it. How much data am I bringing in? How much is going out? What does that do to my cost? That's going to be the same problem that any particular use case that comes through needs to figure out. So if you can get some patterns down around that and then share those patterns with other teams and other products that come through, it's really going to be beneficial for the organization as a whole. You've got cloud infrastructure and edge infrastructure. These are things that are common that as you span into a new market, you decide to make changes to where you're going to compute, you want to be able to, again, easily infrastructure as code, stand up your infrastructure, drop your code on, and do your processing and have it work every time, no matter where you're pushing it to. Security spans the whole thing. I need to make sure that security isn't being developed every time for every use case. So defining the patterns that allow me to be able to pick up the same criteria, the same constraints, the same auditing, no matter what use case I bring into it, is a really beneficial thing. Looking at the next slide here, we're going to, yep, there we go. We're going to look at, these are categories of common themes that emerge no matter what solution you're trying to implement. If you're only implementing one, you're still going to have to look at all of these. If you're implementing 10 or 100, you're going to see patterns emerge from each of them that seem to be similar, even though the implementation may be different. So you need to train a model. You need to push that model out. That's going to be a pattern around model training and pushing the model out, independent of whatever the model is. Same with the data transport, data management, transformation, and monitoring and management of the data. Those patterns will start to emerge, and same would go for all of these different categories here. So these are things that we've thought about and have started implementing and putting practices around. And if I can go to the next slide. Perfect. We've built a repository as a placeholder to capture these sort of artifacts, so that as organizations come through our Edge Technology Center, that we can help them through the process and share what's worked and what isn't worked, and they can bring these things into their organization and move it forward. We go into the next slide. This is just a quick overview of a lab that we put together and how the architecture behind it, how we get started. We use these CloudFormation templates to be able to re-provision the environment every single time, tear it down when we're done, the configuration guide for it, what goes into it, depending on where it's getting deployed. And then these are the YAML files that define the CloudFormation templates. So just as an example, if I need to provision infrastructure, this is what I'm using this as a starting point. And we've decoupled the various stacks to show that if one stack for provisioning infrastructure or provisioning the wavelength zone, that can be used in another stack to get deployed. This one here, the site edge, again, another example of I need a repeatable process to be able to manage and monitor my devices. As I look at using AWS Greengrass, it's a way to be able to provision, monitor, apply certificates, and deploy it in a consistent manner. Going on to the next slide, I want to hand this off to Arvin so he can share kind of a summary of the things we've just discussed.
Thank you, Scott. That was a great description of how we look at Edge and IoT services. So, but this is just to bring it all together. Right. So if you see, we started off by typically looking at a particular use case, right? And so where we start looking at something within a bottling plant, right? So we then took it forward. We analyzed it with our decision matrix, where we identified all of these different parameters like latency, security, connectivity, the kind of data management and remote support required. Right, so that helps us to then evolve into the architecture, right? So which is the design phase, where we then say, okay, this is what the solution architecture for Edge and IoT looks like, right? And then we move on to saying, okay, so how do we develop and implement it, right? So which is where we use these patterns, right? And so we say that let's go into the repository and see what patterns, right? And so will be required for an architecture of this kind. And then using the repository, we're able to pick and choose and then say that, okay, this is what we would like to do. All right, so these are the particular components. For example, you might not need too much around the deployment aspect, right? So you might want to focus more on the connectivity aspect, right? So more about how do you do AI/ML as this thing as close to the device as possible. So depending upon what comes out, right? So you'll be able to develop and implement, right, so a particular solution. And then obviously, right, so looking at the scale of scale of the solution, whether it like Scott was mentioning, if you've got multiple use cases within your organization, right? So you would then look at trying to harvest it and creating a repository for yourself, right? So this is a way of trying to bring all of this together here. Uh, so what we have done at ACS is in trying to look at this and then seeing how an approach like this can be expanded across multiple industry use cases. So like going back to some of the points that Scott was talking about, irrespective of whether it is a smart product, right? So for example, it could be tools you're using which has sensors built in within that, right? So it could be equipment that could be used within the organization, or it could be some healthcare equipment that you might have, right, and developed or manufactured, whether it is scanners, CT scanners, or whether it is something as simple as it could be some kind of a band you have been wearing for monitoring, right? So different kinds of health parameters. So irrespective of that, or if it is complex manufacturing setups, right? So whether you have a line manufacturing, whether you manufacture discrete products, or whether you have a process servicing manufacturing setup. So across this, and or whether it's more sophisticated ones like robotics or drones, what we have seen is that these parameters can be effectively used to arrive at specific solution architectures, right? And on which you can apply the patterns in very specific manners. So what ACS has developed within our labs is to develop quick starts across the board so that it makes your task easy in terms of having to come out with different kinds of edge solutions. So what we have done within the lab is to establish an ecosystem where we are looking at scenarios across multiple industries. What we also have is a multi-platform environment. So we are not bound to one particular platform. We have partnerships across the board, whether it is with and so whether it is technology providers like NVIDIA, Intel, Arrow Electronics, or AD-Link, or whether it is the more platform providers like AWS, Azure, GCP, plus even some of the telecom carriers like Verizon, AT&T. So we have partnered with all of these major providers and using those services. Right, so we are in the process of setting up this whole lab. We already have quite a few pre-built components and quick starts. So, but these are and so will continuously evolve, right? As some of the services that are being released evolve too. So that's what we bring to the table, and essentially what we are offering is an environment where you can emulate different scenarios and different kinds of architectures, whether you're looking at an on-site edge deployment, whether you're looking at a local or a private network, or whether it is a carrier-driven and so kind of an environment. All of this is something that we can emulate within the ACS Edge IoT Lab. So where we can help you is in terms of whether you'd like to do any assessments and try to create a roadmap, or whether you'd like to implement some pilots within our secure sandboxes, or whether there is an end-to-end solution implementation, for which you already might have a use case, but then right, so you need the jump start to actually move into implementation cycle, or even in terms of going all the way up to doing large-scale deployments and rollouts. All of these are capabilities that come out of the ACS Edge IoT Lab. So this is something that is already being offered. We already have a few customers lined up, mainly global manufacturing organizations who are in one way or the other trying to create an edge platform of their own, or uh, trying to look at what's the best approach and what's the best set of architectures which they need to adopt. So these are some of what ACS can do for you. Now, and obviously we're almost at the end of the webinar right now. So definitely thank you all for attending. So do not miss our next webinar that's coming up on April 15th, which is about 4 weeks from now, where we will be doing a deep dive into some of the architectures and environments that Scott was talking about today. So we'll go deeper into the environment. How do you set up an edge IoT architecture? What are the different services that go within that? So some of the repository and the quick starts that we were mentioning today, how is it designed? How do you handle it when you're actually taking it into deploying within an environment? So we'll talk about all of that in our upcoming webinar in 4 weeks from now. So please do connect with us. Send us a note at edgecomputing@acsacorp.com, and we'll be happy to support you in any way that we can. You'll definitely be getting a handout and so within the next day. So you'll receive a link to a 2-page brief. So we are always happy to answer any questions. The ACS Solutions team is standing by. And of course, you'll have a replay of the entire webinar, which will be available both for sharing and for reviewing, or if you'd like to circulate it within and so your team members who might not have been able to make it today. So thank you again for attending. I'm going to open up the floor for any questions and so which you might have so regarding any of the particular topics that was discussed today. So I do see a couple of questions that have come in. So let me read that out. So the first question is, what is the dependency on 5G to implement some of the edge architectures that we spoke about today? So what we're seeing is that it's a while, obviously 5G is one of the key enablers for edge computing. What we're seeing is that there is really no strong dependency on 5G itself. So you could have a private network which already has a reliable high-speed connectivity into one of the local clouds and cloud data centers, for example. So you could still, for example, go with a site edge, like Scott was describing, which is our Model 1 architecture, and you'd still be able to connect up any of your IoT devices through that. Now, obviously, if your use case is more towards smart products, then yes, right? So you would still have to depend on 4G LTE for any kind of a connectivity. But a lot of the providers are rolling out their edge services across most of the metro centers in North America and a lot of other cities around the world. So there's always a fallback mechanism that they have built in, where if there's no 5G available, you do get 4G LTE. Obviously, you may not get the same kind of performance, but not having 5G is definitely not going to stop you from from making use of any of these particular components. The second question is more in terms of so the examples that we have shown, they all seem to be AWS. So is this very AWS centric? So and like we were saying, right? So the lab is platform agnostic. Right, and so we're trying to create a multi-platform kind of an edge IoT environment. So we are not bound to any one particular platform or one particular technology provider. So this applies across the board. We'll be able to combine different kinds of edge gateways, for example, with different kinds of IoT devices, and then being able to plug that back into multiple kinds of services. Obviously, a lot of the edge services are still evolving, but we do know the direction that some of the major providers are moving forward into. So, but no, we are not bound, and even you will not be bound to any one particular technology provider in this particular case. The third question is more about how do we start, right? So what would we recommend is a good starting point if we had to start looking at within our organization. So what we typically recommend is to start off with a series of workshops, which is what we have been recommending to all of our other customers, and where we conducted these workshops. So what we recommend is that start off by having a workshop, bring in all your key stakeholders, and we'll start looking at what kind of use cases would you be able to map into. So whether you're trying to do just a basic condition monitoring, whether you're trying to do some kind of asset management, or whether you're trying to do some kind of process analytics, or you're just trying to provide value-added services to some of your products. So irrespective of whatever the business scenarios might be, right, so we'll be able to identify and then pick up a couple of those use cases and then go through this particular process of what we just described. Right, so use our decision matrix, understand what are those parameters that are really important to your business scenario, and then use that to evolve a solution architecture, identify the patterns, right, and then go back into our repository, make use of some of the quick starts that we have developed, and see the applicability of some of that to your particular use case. So those are, I think, some of the key questions that we picked up. There are a couple more that I repeat of the others, but we'll be happy to answer any other questions that you might have. So with this, I'd like to close the first part of the Building the Edge series from ACS Solutions. So please feel free to reach out, and obviously you'll see a lot of this content available even within our web pages, and look forward to similar kind of attendance even for our second webinar too.
Yes,
Thank you very much. Thank you, everyone, and I look forward to more such conversations. Have a good day.